take a look at section 2.4. In section 2.4, we'll look at graphing what are called linear inequalities in two variables. How we know that these graphs are going to be different than everything else that we've seen in this chapter is because we're going to be looking at specifically graphs that have inequalities, meaning they'll have a greater than or a less than or greater than or equal to. So we'll graph the lines at least to begin normally. But we have to be careful what kind of line we draw. For instance, if it is one of the two graphs with the equal to, either the greater than or equal to or the less than or equal to, we're going to be drawing that graph because of the equal to with a solid line. However, if we have the less than or the greater than without the equal to, either one of those two is going to require us to draw a dotted or dashed line. Why is that? If you have the equal to on the greater than or the less than, then it means that you actually want to include, that's why they say equal to, you want to include the actual line, any points on it. However, if you just have the greater than or just have the less than, that means we want everything that's not including that line. So to make sure that we know we're not going to include any of the points on the actual line, that's why we draw a dotted or a dashed line. Now, that's not the only difference. We also, when we have these inequalities, besides doing solid and dashed or dotted lines, we also have to shade one side of the line or the other. So that's the second part, is to shade the line. Now, how do you know which side to shade? You cannot just go with one side of the graph or the other based on which way it's pointing. You have to actually test something. So you pick any point that you want to test, as long as, and this is a big if, as long as the point is not on the line. We want to choose the easiest point we possibly can to plug in, which is usually the origin, 0, 0. But we can only use that point as a test point if our graph doesn't go through it. If the graph doesn't go through it, choose another simple point, but you can't use that one. Choose something else that the line is not on. Now, what do you do if the point works? Well, if the point works and we get a true statement, then we'll shade the region that that point is on. If whatever our test point is doesn't work, then we don't shade the side that that point is on. We shade the other side that the point is not on. Okay, I know that's a lot of wordiness, so the best way to learn how to do this is just see them done. So first of all, let's take a look at this first example. Y is greater than or equal to x plus 2. So let's take a look at this graph. Because of the equal to here, the equal to tells us that we should have a solid line. Now, this graph is also in the form y equals mx plus b, and that will help us actually graph our solid line. So we'll always start with our b, our y-intercept, which on this graph, our b or y-intercept is this plus or positive 2. So I'm going to start up on the y-intercept here at 2, and then I'm going to use my slope. The problem with my slope is I can't quite see it. It's whatever's in front of the x. Well, I can't quite see it because it's a hidden 1. Well, how do I use a slope of 1? Remember that what's going to be on the denominator is another hidden 1. So we can look at this as rise over run. Because the rise of 1 is positive, that means we'll be going up 1. Because our run, which is also positive, is also a 1, we'll be going right 1. So from where we started at positive 2, we'll go up 1 and right 1 to get our second point. Now be careful, I know it's easy to just go ahead and draw your line, but it's supposed to be what kind of line? A solid line. So I can draw my line through my 2 points and it is supposed to be a solid line. That is half of the problem. The other half of the problem is figuring out which side of the line to actually shade. So in this part, you need to actually test a point. You need to pick a point and test it. Now our line does not go through the point 0, 0. So I'm going to use the point 0, 0. And we're going to go ahead and test that. So we're going to test the point 0, 0 by plugging it in to the original inequality, which is y is greater than or equal to x plus 2. Plugging in the point 0, 0 means we're plugging in a 0 for x and a 0 for y. We're going to plug in a 0 for x and a 0 for y, and let's see what we end up with. Well, that will give us a 0 is greater than or equal to. On the right-hand side, we'll have 0 plus 2, which is just the number 2. Now let's see what we have. We have the statement 0 is greater than or equal to 2. What do we know about that? Well, we know that 0 is never going to be greater than or equal to 2. What does that mean about our point 0, 0? It means that that point didn't work. Well, if that point doesn't work, that means we don't want to shade that side of the line because it didn't work. We want to shade the other side of the line. That's what's going to work. And that's it. But that's a lot of work. We have to do 2 parts. We have to figure out how to graph it, and we have to shade it. That's the 2 parts of your inequality. Let's try another one. Let's take a look at the graph. 2x minus 3y is less than 6. So you can leave it like this to graph it, or we could put it in slope-intercept form. It's up to you. If you leave it like this in standard form, the easiest way to graph it, because it's in standard form, is to plug in 0 for x and 0 for y. So you could do that. So if you plug in 0 for x and 0 for y, that'll work. But most students at this point like to put things in slope-intercept form, y equals mx plus b, so that's what I'll do. But either way works. So how do I put this in y equals mx plus b form? Well, I need to get y by itself. So we will go ahead and subtract the 2x from both sides, which will give me, let's see, negative 3y is less than negative 2x, and that's a positive 6, so plus 6. And then we'll divide both sides by a negative 3. Beware of this. What did we just do? We divided both sides of an inequality by a negative. We learned this earlier in this chapter. What does that do? That changes the direction the inequality is pointing. So if it was a less than, it's now a greater than. What also do I have is I have a negative 2 divided by a negative 3, which will give me a positive 2/3 in front of my x. And then what else do I have? A positive 6 divided by a negative 3 is a negative 2. Okay, now it's in slope-intercept form. How do I graph it? Well, remember, I want to start out with my y-intercept, my b first, which is negative 2. So I'd start down here at negative 2. Negative 2. And then I'd use my slope, which is positive 2/3 as my rise over my run. And what that would tell me to do is to go up 2 and, because it's positive, and my run is also positive, to go right 3. So go up 2 and right 3. Be careful before you draw your line. What kind of line is it when you have an inequality? Well, in this particular one, we had a less than, not a less than or equal to. So it's a dotted or dashed line. So I can draw my line through my points, but it needs to be a dotted or dashed line. Okay, still not done. I still have to figure out which side of the line to shade. Well, I need to pick a point to test that is not on the line. Well, I can still pick 0, 0 like I did on the last one. Why? Because it's not on my line. So I'm going to test 0, 0. So I am plugging it into the original. I could plug it in to the one where it's y is greater than 2/3 x minus 2. But why should I? I might have made a mistake somewhere. If I go plug it back into the original, I haven't touched that one. So I haven't made any mistakes with that one yet. So let's plug it into the original so I don't have to worry about mistakes. So remember, I'm plugging in a 0 for x and a 0 for y. So if I plug in a 0 for x and a 0 for y, well, 2 times 0 will give me 0, and 3 times 0 will also give me 0. So that means that whole left-hand side is just a 0. Now the other side was just a 6. So the question is 0 less than 6? And the answer is yes, absolutely. So what does that mean? It means that this time our point 0, 0 did work. So what does that mean? It means because 0, 0 did work, I want to shade the side of the line that 0, 0 is on. Well, 0, 0 is on this side of the line. So I'm going to shade that side because 0, 0 did indeed work. And I'm done. I have my dotted line with the shading correct. Now, just to kind of talk about how you would graph these in my math lab, we've talked about this a little bit in previous sections. You would choose the line tool. You'd plot your 2 points. On your line tool, there's an option for solid or dotted. And on this one, you would have selected dotted. Then somewhere around in there should also be like a little paint bucket. And what you would do is you'd click somewhere, I'd probably click 0, 0 over here with my paint bucket, and it would automatically shade in your entire graph up here for you in one fell swoop using that little paint bucket tool. So that's what you need to do in my math lab, is use the little paint bucket and just click somewhere over here.